Hey everyone. In this mini lecture, we're going to look at the topic of anti-differentiation. So we can say that we're looking for the antiderivative. And we can say that the antiderivative of some function we'll call f of x is the set of functions f x plus c. So I use here a capital F representing the antiderivative of the function with the little f, f of x. So this we say such that when we take the derivative of that f of x, capital F of x plus c, right? If we take the derivative of that, and I should erase that and make that a bracket. That in the bracket, that's the antiderivative plus this c value, this constant. If we take the derivative of it, we'll get our function f of x. So the c is known as the constant of integration. So anti-differentiating is often called integration. Anti-differentiation is often called integration. So to indicate the antiderivative of x squared, let's say, the antiderivative of x squared is x to the third over 3 plus c. To illustrate that, what we need to do is we say, and this is the integration symbol, integral of x squared with respect to x, we say is x to the third over 3 plus c, right? Where this integral symbol and whatever your function is and dx with respect to x, that's used to represent the antiderivative of f of x. So more generally, if I took this, we can say that the integral of f of x with respect to x is equal to f of x plus c. Remember that capital F, meaning antiderivative, plus c, that constant of integration. So f of x plus c is the general form of the antiderivative of f of x. All right, so we take this understanding and let's do some examples. So this example asks us to determine the indefinite integral here. So we're saying, what is the integral? Integrate 8 with respect to x. Looking at that, I'm thinking to myself, okay, what's the antiderivative of that? I would say 8x, and then we always have to add that c, that constant of integration. Let's check and see why. Well, we said to be the antiderivative, if we take the derivative of it, so we take the derivative of 8x plus c, what do we get? Well, the derivative of 8x is 8. The derivative of some constant, any number, is 0. So 8 plus 0 is 0, and we get 8, which is what we have here. So now we know that this is correct. 8x plus c. All right, so the main thing is to remember that when finding the integral, you're looking for the antiderivative, which would be the value that when you take the derivative of it, it will give you the original function in your question. All right, so if we try another one, it's the integral of 3x squared with respect to x. All right, so looking at this, 3x squared with respect to x, I would say that this is x to the third plus c, right? You're thinking about something that when you take the derivative of it, will it get you 3x squared? And I'm thinking, yes. Let's go ahead and check. So if I take the derivative of x to the third, and don't forget the plus c, the derivative of x to the third, we can just use the power rule that we know from differentiation. We get 3x to the second plus the derivative of any constant. Remember, that's not a variable, that's a constant, is 0. So 3x squared plus 0 is 3x squared. And that's what we got right here. So now I know that it is correct. So there are some basic integration formulas that you want to be aware of. There's usually a list provided in most textbooks in the appendix portions, but I'm just going to give a couple here. So if we take the integral of k with respect to x, then we should get kx plus c. Right, and here, of course, k is a constant. It's a coefficient there. And let's do another one. We take the integral of, let's see, x to the n power with respect to x. Then the formula here is x, raise that n, but you add 1 to it according to this formula, and then you divide it by n plus 1 as well. And then you don't forget that constant of integration. And then this is provided, of course, that n does not equal -1. All right, so if we take a look at this example, the integral of x to the 7th with respect to x. So in this one, it looks like we would use one of those formulas that we just looked at. So this would be x to the 7, and remember the formula said to add 1 and put it over 7 plus 1 as well, plus c. And then this will be x to the 8th over 8 plus c. And if you want to check it based on what we did earlier, you would just go ahead and take the derivative of what we have, and that should get you x to the 7th power back. And maybe another one we can try would be, let's go ahead and take the integral of the square root of x with respect to x. All right, so we know from basic definition from our pre-calculus or college algebra that the square root of x is equal to x to the 1/2 power, right? That numerator represents what you're raising the x to, which is the first power. The denominator represents the index of the radical, which is square root. So we can go ahead and rewrite this as x to the 1/2 power with respect to x. That makes it easier on us. And now we can apply that same rule as in the previous example, right? When you're raising something to a power and you're taking the integral, it says that you can make it x to the 1/2, add 1 to it, and then write it over 1/2 plus 1. So that gets us, looks like, oh, I'm sorry, and we can't forget that constant of integration. Can't forget that constant of integration. And then we can go ahead and do the math. It looks like in the denominator, 1/2 plus 1, that gets us 3/2. The 1/2 plus 1 at the top gets us 3/2, right? So then the 3/2 in the denominator, it's really saying you multiply times this whole entire fraction. So you get 2/3 x to the 3/2, and then you say plus c. And just in case you were wondering how we got the 2/3, we did the math down here as far as a fraction being divided by another fraction. In this last example, it looks like we have several terms that we're finding the integral of. So just as we did in differentiation, where we would use the sum and difference rule, we would do the same thing here. We could say to ourselves, let's make this the integral of 3x to the 5th plus the integral, and sorry, I should write the dx, plus the integral of 7x squared dx, plus the integral of 8 dx, right? Just as you did with differentiation, you broke each term up into separate pieces. We do the same thing for integration. Just as you did for differentiation, a constant can always come outside, right? So we can do the same thing here too. So now we have 7 times the integral of x squared. All right, and now we can just do this piece by piece. So now you would just go ahead and recall the rule that we went over, that definition that we went over when we have x to the n power. So this becomes x to the 6th power, right, over 6, and this is times 3, plus x to the 3rd power over 3 times that's 7, and this is plus. This one's a little bit different, right, because we don't have something raised to a power, but remember the thinking of it. We're going to say, what would we take the derivative of and get 8? If we took the derivative of 8x, yes, we would get 8. So that's the antiderivative of 8x. Okay, and now just a little bit of arithmetic to perform. 3 times x to the 6 over 6, 3 over 6. It gives us 1/2 x to the 6th plus 7/3 x to the 3rd plus 8x. And then do not forget your constant of integration.